Okay, so at a point where v is not equal to 0, the quotient u of v of two differentiable functions is differentiable, then the derivative with respect to x of u over v, this is called our quotient rule, is v times du over dx minus u dv over dx all over v squared. So again, derivative of u with respect to x, derivative of v with respect to x. Now let me show it using prime notation. I think it might be easier to remember that way, but we're going to use it both ways. Or you could write it as u over v prime will be v u prime minus u v prime over v squared. Okay, so these are again the same. Here I did dv over dx. There I just wrote it as v prime. But with this one, unlike the product rule, order matters, as it always does with division. Okay, for example 1 here, find y prime if y equals x plus 2 over sine x. I'm still going to probably find my u and u prime and stuff off to the side and just plug them back in. I think that's an easier way to do it. Nice way to organize it. So in this case, u is always the numerator. So u is x plus 2, and u prime would just be 1, which is, I'm always happy when I see that. It makes the math easier. V would be the sine of x. V prime would be the cosine of x. And then to find our derivative, again, y equals v u prime minus u v prime over v squared. A way that I remember it, I know that this top looks kind of like the product rule, but it's got a minus in it. Like I can remember that. But I remember I always start with v and I end with v, right? Use the original v function here in the top left, right? This first product. And then I use v squared. So it starts with the bottom and it ends with the bottom. That's the way I keep it straight. We'll talk about some other ways people have. There's rhymes and things. Maybe we'll look at next week. That's y prime there. So y prime is the sine of x times 1 minus x plus 2 times the cosine of x over the sine squared of x. So again, v u prime, u v prime, v squared. Remember, we write the sine squared like that. Now, to finish this up, once you get here, it should be pretty good, but this negative here is going to get the cosine gets distributed, or the x plus 2 gets distributed, and the negative goes with it. That negative will get you. Like that's the one to watch for. So we're going to get sine of x minus x cosine x minus 2 cosine x over sine squared x. That makes sense. This negative got distributed into both of these. That's really essential to note. There are a lot of ways we could try to simplify this and modify it, but this is a great final answer. We're good. Okay. You could remember doing trig identities and trig proofs in pre-calc, I hope, and you know that it got pretty ridiculous sometimes. If you wanted to try to simplify this, that's what you'd have to do. Pretty much if you expand it, collect like terms on top and bottom, you're good to go. Yeah, that should be that one. Okay, for our next example here, we have y equals the sine of x over x squared. Let's look at this one. All right. Now, we did the warm-up, correct, today, which was y equals x to the negative 2 sine of x. Did you realize that's the same equation? Right. So what we want to do is let's go ahead and use the quotient rule to do it, and then we're probably going to find out that we don't ever really want to do the quotient rule to do this problem because it's harder, mildly harder. Okay, but let's take a look just to see that our answers will compare. Right? Right? So it's a good investigation here. So if we're going to find dy dx, right, we know that dy dx is v du dx minus u dv dx over v squared, right? Starts with a v, ends with a v. So we have that u is the sine of x, du over dx is the cosine of x, right? Again, I'm using the other notation. If you don't like it, I don't blame you, but we've got to get used to it. Right? So that we do have our u and our v. They're really easy to split. Like it's obvious what the quotient and denominator are compared to the product rule. But now we want to go ahead and plug into this. And we get v, which is x squared, times the derivative of u with respect to x, which is the cosine of x, minus u, which is the sine of x, times 2x, which is dv dx. Now it's going to be over v squared. So v was already, let's write it as x squared, squared. Right, we're going to square the square. So now at this point, to simplify the numerator, we get x squared cosine x minus 2x sine x over x to the fourth. Now that doesn't match our answer from the warm-up, which I think I've erased. But this should look like some of our review sheet problems. Is there a common factor on top of x? So I can take the numerator and I can factor out an x. We get x cosine x minus 2 sine x over x to the fourth. Then can I go ahead and cancel these x's? Well, an x, the one on top and then one from the bottom. And that gives us dy over dx is x cosine x minus 2 sine x over x cubed, which is exactly what you had on your warm-up. I think we might have had the negative first, but it's the same thing. Right? So you just want to check that, confirm it, and just kind of make it, this was not hard, but it was kind of a lot of writing, correct? When you got to this point where you had to simplify a quotient rule, it was kind of a pain. If you compare it back to the warm-up, which I hope you wrote down, because you always write down warm-ups, right? Because they're awesome. And then we could compare them. You see that usually if you could get a product rule, is usually preferable to a quotient rule, right? And then a power rule is preferable to all of them if you can write it using a power rule. And then we'll learn other rules where we can do some kind of fancy stuff.